Okay, so for letter D, one tendon at a time. So ibig sabihin yung ating jacking operations will be 10, no? 10 yung ating operations, and then our formula will now be this one, no? 1/10 times yung ating value for nakalculate natin sa pre-tensioning, no? Pre-tension member. And then magiging multiplier natin dito is yung unang 9 tendons lang, yung magiging ano niya. And then yung first one natin, again, yung full yung loss niya. Then yung second, third, fourth, 4, 3/9. Okay? So, yan yung maging formula natin sa kanya. So, pag kinalculate 1/10 multiplied by 60.194 times 9/9 plus 8/9 plus 7/9 plus 6/9 plus 5/9, 4/9, 3/9, 2/9, and then 1/9. Okay. Our answer will be the same lang, no? 30.097 MPa lang. Okay? Ibig sabihin yung total loss na na-experience nung buong structure is the same. Kahit mag-iba tayo ng sequence, no? And then yung sa last, ang hinahanap na last is all tendons are simultaneously tension. So pag simultaneous yung yung ating pag tension ng member o nung ating prestressing strand, yung ating elastic shortening na will be equals to 0 MPa. Okay? So yan po yung sa ating elastic shortening. Question po dito sa elastic shortening natin. Okay, next. Okay. Let's go dun sa still relaxation tayo, still stress relaxation. So stress relief tendon suffer loss and pre-stressing force due to constant elongation with time. So balikan lang natin kung ano yung meaning ng stress relief na tendon. So ito yung paano ini-stress o ginagawa yung mga tendons natin. Okay? So we have from our base material, pinapatent natin siya. Okay? Or ini-heat for about 800 degrees Celsius to make it homogeneous. And then, ayan, sinashape natin siya dito sa cold drawing, and then for stranding, ayan. Then nag-iiba siya dito kung depende siya kung stress relief or low relaxation tayo. Okay? Yung difference ng dalawa pag stress relief yung atin is ibig sabihin normal yung ating relaxation value. Tapos kapag low relaxation tayo, 25% less yung relaxation niya. Yung tinatawag nating relaxation is yung decrease in pre-stress. Okay? So dito, the magnitude of the decrease in the pre-stress depends not only on the duration of the sustained pre-stressing force, but also on the ratio of the initial pre-stress to the yield stress of the reinforcement. Initial over yield strength natin. So this loss is termed as stress relaxation. So as you can see dito sa table, dito naman sa graph, ng ratio natin ng FPI over FPY versus time, makikita natin na yung pre-stressing steel natin with constant elongation maintained over a period of time have shown that nag-exist yung decrease in pre-stressing force. Ibig sabihin, nagre-relax na nga yung steel natin. Mula doon sa pagkaka-stress niya, kumaga nababawasan yung pre-stressing force natin due to relaxation. Okay? And ito, existent siya dito sa strands natin. Okay? So, si code is meron siyang limitation for the tensile stresses for tendons. and given as follows. So kapag stress relief still tayo, na-assume natin ang FPY natin ay equals sa 0.85 ng FPU. And for low relaxation still, ang FPY natin is 0.9 ng FPU. Then dito, tensile stress and prestressing shall not exceed the following. Kung due to sa prestressing still jacking force, 0.94 FPY yung value natin. So, refer na lang kayo dito sa table na to kung gagamitin natin. Okay? Then, punta tayo dun sa formula for still stress relaxation. So, may pinropose si na Magura et al. Na formula for the relationship nung pag-decrease nung stress sa pre-stressing still natin, no? And they propose itong formula na to na FPST, so meaning yung stress in pre-stressing still at any time t is equals dun sa FPI times 1 minus logarithm of t over k times FPI over FPY minus 0.55. Wherein yung k natin dito, refer kung anong klase ng strand natin. So kung 10 yung value niya kapag stress relief yung strand, and then 45 kapag low relaxation strand yung gamit natin. And then yung T natin dito refers dun sa duration ng loading natin in hours, no? Kasi si stress relaxation is a time-dependent loss, no? Kaya meron tayong time dun sa formula natin. Okay? And then the stress loss due to pure relaxation can be calculated mula dun sa initial pre-stressing force natin na FPI, ima-minus natin yung kanyang pre-stressing at any time, no? So ito yung conditional bawa after 5 years, ito yung value niya. So pag pinag-minus natin yon, yung mula doon sa initial o sa original pre-stressing natin at transfer minus yung ating pre-stressing stress at any time, makukuha daw natin yung change in pre-stressing relaxation, yung relaxation loss natin due to still, no? So, mula dito sa formula natin, to FBI natin, no? Pakita lang natin kung saan nanggaling yung formula yan. So, FPRT, so FBI minus FPST. Okay? Doon sa taas nakuha natin na FBI minus FBI 1 minus log T of K times FPI over FPY minus 0.55. Okay, yan yung formula natin. Then pag ito dinistribute natin dito, okay, ang mangyayari ngayon, magkakameron ng minus FPI. So magka-cancel dito. So matitira na lang is yung FPI, yung negative FPI times yung negative log T. No? Kaya matitira na lang ay ito na lang. No? Dito ko nang lalagay. Yan. Kaya ito naging positive to. Kasi ito negative FPI times itong negative term na to. So ito po yun. So ito lang yung natirang formula natin. Okay? So yung T1 natin dito sa formula, so ibig sabihin si T natin, pwede natin siyang i-represent as an interval, no? Depende sa given sa problem. So pwede siyang maging itong log T, pwede siyang ma-represent as log of T2 minus log ng T1 kapag meron tayong given na dalawang time durations, no? Or may particular time tayong kino-consider. So pwede siyang maging ganyan. Wherein yung T1 is the time at the beginning of the interval and yung T2 is yung time at the end of the interval from jacking to the time when the loss is considered. Okay? So yan yung formula for still relaxation. So using that formula, do sa same problem natin, find the relaxation loss and pre-stress at the end of 5 years. So ang time natin na given is 5 years. Okay? Pero dito yung time na kailangan natin is in hours, no? So, kailangan i-convert natin si 5 years in hours. So, sa 1 year, meron tayong 365 days. Then, in 1 day, meron tayong 24 hours. Okay? So, 5 times 365 times 24, that is 43,800 hours. Yan yung time natin. Assuming a relaxation loss from jacking to transfer, from elastic shortening, and from long-term loss due to creep and shrinkage over this period is 20% of the initial pre-stress. Okay. Assume also that the yield strength FPY is 1571. The jacking force on the tendon was 1396.5. Okay, so kung papansin ninyo, ito na-calculate natin na 1396.5. Pag chinek ninyo, this is equivalent dun sa 0.75 ng FPU natin kanina dun sa first problem natin. Okay? So, dito, may sinabi siya na may 20% loss from elastic shortening, okay? From creep, shrinkage, okay? So, meron na siya nangyaring 20% ng initial pre-stress yung equivalent na loss. Okay? So, kailangan natin makuha yung initial stress natin na gagamitin doon sa formula natin for FPR. Okay? Yung formula natin ay FPI multiplied by log T over K FPI FPY minus 0.55. Okay? So, kailangan natin yung value ng FPI. So, kunin muna natin yung value ni FPI base dun sa given natin. So, na yan. Okay, so kung magkakameron siya ng loss na 20%, so ibig sabihin 0.8 na lang ng FPI yung gagamitin natin, no? Sabihin dito, 0.8 na lang yung gagamitin natin. So, tawagin ko na lang F prime PI is equals to sa 0.8 ng FPI natin. And nakalagay dito na equal siya sa 1396.5. Okay, so 0.8 nung 1396.5. Okay, so 0.8 times 1396.5, that is 1117.2 MPa. Ito na lang yung natira doon sa initial pre-stressing natin. Kapag minus pa natin yung stresses due to shrinkage, creep, tsaka doon sa elastic shortening based doon sa problem natin. Okay? So once na na-calculate na natin yan, kukunin natin ngayon yung value ng ating dito. Substitute na natin dito. Okay? So FPI natin is yung remaining 1117.2 log. And then, value natin is 43,800 all over. Yung K natin, since tayo ay, ano ba tong problem na to? Yung first problem natin kanina is what type of beam? Balikan natin, no? Ayan, pre-tension net, no? Pre-tension, pre-stress beam. So, pre-tension. So, pag pre-tension, according to sa formula, tapos, hindi naman nakalagay kung stress relief, no? Kung wala nakalagay kung stress relief, let me check lang, no? Stress relief. Kung hindi naka-indicate na low relaxation siya, ang assumption natin is always stress relief yung ating strand. Okay? So, gagamitin natin dito ay 10. Okay? Multiplied by FPI which is ang value na calculate natin is 111.7.2 divide sa FPY natin given as 1571 minus sa 0.55 natin. Okay. 1117.2 times log 43800 divide 10 multiplied by 1117.2 divide 1571 minus 0.55 is equals to 83.56 MPa. Okay? So, ito na agad yung value natin upon calculation or substitution dun sa mismong formula natin for still relaxation loss. Okay? Next, after still relaxation, we now proceed sa another method sa kanya, pero wala na ako example dito. No? So, may si ACI-ASCE method for for relaxation loss, meron siyang sariling formula wherein ibe-base niyo yung value nung KRA, J at C dito sa formulang to based sa table na pinrovide ni ACI-ASCE. No? Pero dito kino-consider niya na si relaxation is dependent dito sa tatlong losses natin which are yung elastic shortening natin, yung ating creep, and then yung ating shrinkage. Pero hindi pa natin na-discuss si creep tsaka si shrinkage, no? So hindi pa natin siya maka-calculate using this method. So dito, yung KRE, J tsaka C. So ito si KRE at si J, dito natin makukuha sa table 4-5 sa libro ni Lin TY, no? Tapos depende siya sa type ng tendon natin. Okay? So check nila yung ano ng type ng tendon, then yun yung magiging value ng KRA at J. And then sa value ng C, dito naman siya magde-depend dun sa ratio ng FPI over FPU. And then dun sa ayan, kung anong klase siya ng wire, no? Kung stress relief siya or low relaxation wire siya. Okay? So, again, this is another method for computing the value for relaxation, pero wala tayong example for this one, no? Kasi we need the value for creep and shrinkage and elastic shortening to be able to get yung value for loss in relaxation. Okay, next is yung creep. Okay, creep loss. So experimental work over the past half century indicates that the flow in materials occurs with time when load or stress exists, no? So previously we discussed na si creep is kapag meron tayong naka-sustain na load, no? So ito yung additional deformation na nag-exist dun sa mismong member natin once na naka-subject siya sa sustained loading. Okay? And si ACI-ASCE committee has a formula for calculating the value for creep, no? Meron ding formula based from the strain of creep tsaka ng strain ng elastic shortening, pero hindi ko na kinuha yan, no? Ito na lang kinuha ko kasi ito yung ginagamit, yung sa ACI-ASCE na formula. Wherein yung formula niya is KCR multiplied by EPS over EC times yung FCS minus FCS din natin. So, si value doon ng FCR should be reduced by 20% kung lightweight yung concrete. So, pag sinabi sa problem na lightweight yung ginamit na concrete, i-reduce mo ng 0.20% ng 20% pa o times mo ng 0.8 yung full formula natin. Okay? Then for pretension members, 2.0 yung value ng KCR, yung factor na KCR. Otherwise, o ibig sabihin kapag post-tension siya, 1.6 yung gagamitin natin. Then yung FCS natin, ibig sabihin niya is stress in concrete level immediately after transfer. So itong immediately after transfer natin is at initial stage. So meaning, ang present na forces dun sa atin are yung stress due to pre-stressing tsaka yung ating stress due to self-weight. kapag FCS, no? Prestressing plus yung self-weight natin, ang stress natin dyan. Then kay FCSD is stress in concrete at level of steel due to all superimposed dead load applied after pre-stressing is accomplished. So, ibig sabihin nito is due lang siya. So, stress siya. Due siya sa ating superimposed dead load. Okay? Sa SDI lang siya only. So, kaya ibig sabihin dito, yan, pinagma-minus lang natin siya, no? Yung pre-stress due to pre-stressing and self-weight minus yung sa pre-stress na makukuha natin due to superimposed loading natin. Okay? And then papansin natin dito, yung EPS over EC natin, again, that is equivalent sa ating modular ratio na N. Okay? So, ibig sabihin si delta FPCR pala, pwede din natin represent as KCR and FCS minus FCSD. Okay? So, pwede natin siyang ganun din yung formula. Alright, so let's try sa problem. So, compute the loss and pre-stress due to creep in the first example, given that the superimposed dead load, excluding the beam's own weight after transfer, is 5.5 kilonewton per meter. So, given the same properties, so hanapin daw natin yung value for creep. So, again, formula natin for creep loss is given as KCR times N times nung ating ano yung formula na kaya i-multiply natin? FCS minus FCSD. Okay? So, yung FCS nating value, ito, diba ito na din yung na-calculate natin kanina doon sa first example natin. Yung ating stress at steel. Saan na yan? So, ito. So, ito, due to sa pre-stressing tsaka sa self-weight lang. No? So, ito na yung value na yun, 8.459. So, pero pag hindi pa siya na-compute, hindi mo pa siya na-analyze, kailangan bumalik ka dito sa procedures natin. No? Ito. 8.459 yung value natin. So, 8 MPa. Ang kasunod natin hanapin is yung FCSD natin na due to self-weight. Na ang given na unit weight natin is 5.5. Mga calculate natin yan, moment times yung eccentricity natin over yung calculated I natin. Okay? So, moment natin doon, so 5.5 yun. So, 5.5 kilonewton per meter times 15 meters yung length natin all over 8. So, 5.5 times 15 squared over 8. That's equivalent to 154.688 kilonewton meter. Okay? So to calculate that, we have 154.688 times 10 to the 6. Tapos meron tayong 275 kanina eccentricity. And then inertia natin, kunin ko na lang ulit, 400 times 750 cube. Tapos over 12 yun. So multiply natin ng 12 yung taas. Okay? So yung value niya will be 154.688 times 10 to the 6 times 275 times 12 all over 400 times 750 cube. So we have 3.025 MPa. Okay? So meron na tayong values nito. Yung KCR natin, since this is a pretension beam, no? According dito, pretension natin is equals to 2.0. So 2.0 tayo dito. So N na lang yung wala. Okay? N natin is equals to EPS over EC. No? Pero ngayon, since creep ang pinag-uusapan natin, si creep is time dependent siya. Okay? So, ibig sabihin na mababago natin dito is yung sa value ng EC natin. Kanina, ang kinonsider nating FC prime ay yung sa initial. No? Ngayon, ang consider natin ngayon is yung kanyang design strength, which is yung F prime C na 41.4. So ito will be 186,206 divided by 47 square root of 41.4. So yung value ng n natin, 47 square root of 41.4. That is equals to 6.157. So yung ating FPCR will now be equals to 2 times 6.157. Move lang natin to. Okay, times FCS which is 8.459 minus yung FCS natin na 3.025. Okay. FPCR is equals to 2 times 6.157 times 8.459 times 3.025. That is equals to 66.914 MPa. Okay, so this will be our loss due to creep based from the formula that we have. Okay. Okay, next. After creep loss, we have shrinkage loss or SH natin. So as with concrete creep, the magnitude of shrinkage of concrete is affected by several factors. So the loss in prestressing due to shrinkage is given as follows. So meron tayong dalawang method. Yung first one, yung KSH method. So meron tayong factor for KSH for pre-tension members. Ang value niya is 1.0. And then kapag post-tension yung member natin, yung value ng KSH is dependent kung ano yung time na kinukonsider natin. No? So halimbawa 7 days yung kinoconsider natin, ang gagawin din natin KSH is 0.77. Hindi siya 1.0. Okay? Then ang bago lang dito sa formulang to is yung V over S natin, which is yung volume to surface ratio natin, which is dapat given sa problem. Then we have relative humidity natin na should be given also sa problem. Okay? So same formula siya for both system. Iba lang yung value ng K. Ito yung sa KSH method, and then when we try to time dependent method yung gagamitin, ito yung formula natin. So adjustment of shrinkage losses for standard condition. May question dun sa ano kung disregard daw yung FCS. So dito, since loss yung pinag-uusapan natin, pwedeng i-disregard yung sign, no? Kasi lahat ng loss na makakompute natin will be minus nung ating pre-stressing, no? So dito tinanong, di ba dapat ito is negative 8.459? Eh basta alam naman natin to na loss siya. So lagi siyang minus dun sa mismong existing or initial pre-stressing natin. Okay? So again, going back dito, adjustment of shrinkage losses for standard condition as a function of time in days after 7 days for moist. This is not moist cutting, no? Moist curing dapat. Oh, sorry. Moist curing and 3 days for steam curing can be obtained by the following expressions. So pag moist curing after 7 days, ito yung formula. And then kapag steam curing after 1 to 3 days, ito yung formula niya. Okay? Wherein yung strain SH ultimate o yung ultimate shrinkage strain natin is given as 780 times 10 to the negative 6 inch per inch. No? So ito is pwede din siyang maging mm per mm. So same value siya. Okay? Where T is in days naman dito. No? Pag si shrinkage in days yung pinag-uusapan natin, pag yung kanina kay creep in hours tayo. Ay, kay relaxation pala, sorry. Okay? So, kay relaxation is in hours yung pinag-uusapan natin dito. Okay? Ito, no? In hours to. Okay, going back to sa shrinkage formula natin. Ayan. Pero ito, hindi pa ito yung final answer natin. So, to get yung ating FP due to SH, kailangan i-multiply natin si SHT kay modulus ni prestressing strand. Okay? Kasi strain pa lang yung nakuha natin. Para makuha natin yung kanyang shrinkage loss. Okay? So, ayan. So, yan yung dalawang formula natin. So, let's apply sa problem. So, compute the loss and pre-stress due to shrinkage in the previous example at 7 days after moist curing. So, moist curing tayo using both the ultimate KSH method and time-dependent method. Assume a relative humidity, no, RH natin is 70% and the volume to surface ratio, yung V over S natin is equals to 2.0. Okay? So, 7 days tayo. So, pag yung time dependent, yung letter, yung number 1 na formula, itong first equation natin yung gagamitin kapag sa time dependent method. Now, for our KSH method, since our beam from our previous example is a pre-tension beam, ito yung gagamitin nating value or formula, no? O yung K natin is equals to 1.0. Okay? So, try natin dito. So, KSH method. So, yung ating FPSH ay equivalent sa formula natin na yung formula natin. So, 8.2 times 10 to the negative 6 KSH EPS times 1 minus 0.06 B over S times 100 minus RH. Okay? So, 8.2 times 10 to the negative 6. Sa pretension, 1.0 yung KSH. EPS natin is 106. Kasama niya, 106. 186,206. Sorry. 186,206. 186,206 times 1 minus 0.06 times 2, yun yung given sa atin, times 100 minus 70. Okay? So, ating FPSH kapag pretension is 8.2 times negative 6 times 1.0 times 186,206 times 1 minus 0.06 times 2 times 100 minus 70. So, answer natin is 40.310 MPa. So, ito yung pag pre-tension siya. I-try natin ngayon kapag post-tension. Try natin, no? So, ang time natin ay 7 days. Going dito sa table natin, ito yung 7 days. So, ang factor natin ng KSH dapat ay 0.77. Okay? So, since ito, minultiply lang natin ng 1, ito yung value. So, pag kinuha natin ngayon, to multiply lang natin ng 0.77. So, times 0.77, ang value niya pag post-tension siya ay ayan, 31.04 MPa. Okay? Ito yung sa KSH method. Ngayon, try natin yung isang method which is yung time dependent. Okay? Ang given sa kanya is yung ating strain which is shrinkage equals sa time all over 35 plus T para sa moist curing tayo. Okay? ESH ultimate. time natin is 7 days. So 7 all over 35 plus 7 times ito is unit siya na constant times 10 to the negative 6. So ESH natin is equals to 7 over 35 plus 7 times 70 times 10 to the 6. 1.3 times 10 to the negative 4. Okay. So kailangan natin ay yung ating FP shrinkage that will be ESH times EPS natin. So that is equals to 1.3 times 10 to the negative 4 times yung 186,206 natin kanina na modulus of elasticity ni prestressing strand. Okay? Times 186,206. So yung answer natin will be 24.207 MPa. Okay? So 780 times 10 to the negative 6. So ito na yung magiging answer natin for the time-dependent method. And then yung isa is for KSH method. So depende kung anong method yung pinapagamit sa problem, no? Okay, question dito sa shrinkage. Okay, so ayan. So in summary, meron tayong na calculate na losses na apat, no? So dito nangyayari, yung immediate losses natin, ito yung nag-exist kapag katapos nating mag-jacking force, no? After mag-jacking force, nag-exist si anchorage slip, si friction, tsaka si elastic shortening. Okay? So, ngayon na-discuss na natin sa elastic shortening. So, alam na natin kung paano siya i-calculate. Ngayon, kapag nasa lifetime na ng member, no? Nasa transfer stage na tayo or at final stage na nung mismong member natin or existing na yung mga SDL natin, diyan na papasok yung mga time-dependent losses natin. And we have already calculated yung creep, yung shrinkage, tsaka yung ating relaxation. So meron pang isa yung temperature effects, no? So yun yung isa pang kasama for time dependent losses natin, which will be discussed naman do sa part 2 nitong session na to. Okay? So yung sa value nagkaiba kasi ano no, yung isang method kasi is based from statistical value na ginamit ni code. Okay? So depende na lang kung anong na-require sa problem, no? So I'm not sure din dun sa dun sa ano nila, no? Kapag halimbawa magkaiba nga yung value na lumabas. So kung ano yung i-consider na tamang tamang value for shrinkage. Okay? Pero kasi since nag-iba tayo ng value nakadepend tayo sa magkaibang factors, ito is nakadepend sa strain na given by the code, di talaga siya mag-i-equal dito kasi ito is naka-base naman dito sa relative humidity tsaka sa yung volume to surface ratio natin. So, kung kayo papipiliin, kung halimbawa pwede nyo makuha yung dalawang problem, siguro ako, I would choose itong whichever is greater dun sa dalawa. Okay? Para mas conservative yung ma-minus nyo dun sa prestressing force natin as effective prestress natin. Okay? Kasi at least ito, dependent siya dun sa ating relative humidity. Okay? Which is dito sa country natin, medyo crucial to, no? Kasi depende sa klima din yung ating humidity nito. So, naging magkaiba siya kasi magkaiba sila ng consideration ng value. Okay? Pero as I've said nga, kung kayo papipiliin, kung pipili kayo, halimbawa, pwede makalculate yung dalawang values I would choose yung mas larger value para mas conservative yung value ng pre-stressing force natin. Okay? So, ayan. So, next meeting, i-continue natin to with anchorage slip, friction, and yung temperature effects. Okay? Alright, so, this ends our lecture for today. So, may question ba tayong additional regarding dun sa mga na, discuss natin? Okay?